There we go. We should be all good. Got music playing, love it. I can see levels. The previews of the Twitch one's showing an ad. But hey, how we all doing? Music definitely sounds a bit too loud, but oh well, oh well. Anyway, yeah, so Streamsmiths gave the thumbs up for us to work on this instead today. Our cypher project. I've expanded it a bit. I've added some stuff. Basically, yeah, we've got a few new ciphers. So I think there was only the 2 last time. We had our keyboard shift cipher. If I expand that, oh no, not this one here. Our keyboard shift cipher, which is just responsible for shifting letters left and right based on the keyboard layout. So, you know, the top row of keys followed by the second row of keys followed by the third row of keys, and then a mixture of like symbols and stuff. You know, we got capital letters first, and then we go through the lowercase letters. So, you know, capital letters keyboard, lower letters keyboard, and then, you know, symbols and stuff. Lovely stuff. And then we got like a shakes property. So if I scroll down here, we've got this yeah, the get encryption parameters. I think we worked on this last time. I'm pretty sure this is what we worked on last time. We made it completely independent. So like we made it so that the console window that we run is completely independent from the ciphers themselves. So we can just basically rip out one cipher, put a new one in, and it should just in theory work, because each cipher is responsible for obtaining its own information. That's been slightly improved a bit, I think. I've worked on that a bit more. Let's just say that I've worked on that a bit more since the last stream, specifically in that I no longer obtain the key like it used to be in our. So this here, this program.cs is our bunker project. This was our command prompt window. Within the decrypt, it used to ask here, what's the key? You know, you'd ask for what the message is to be decrypted, and then it would say, what's the key? But the problem is there are some ciphers, some new ciphers that I've got that don't actually make use of a key because they're so simple. They're literally like, for example, the @bash cipher. The @bash cipher is quite literally just a reverse substitution cipher. You take the alphabet A to Z, and you flip it around, so it's Z to A. Simple as that, and you just match up the indexes. So A would become Z, B would become Y, C would become X, yeah, X, so on and so forth. That's all @bash is. There's no shifting, there's no shuffling. It's just flip the alphabet, get the matching index, yeah, and then to reverse it, it's the other way around. Simple as that. No key required. It's a super simple cipher. So because of that, I was having an issue where if I just tried to supply no key, like if I just hit enter and left key blank in here in our decrypt, I had some checks to make sure that the key wasn't empty. And I mean, sure, I could just remove that check, but then what about the ciphers that do require a key? How do I handle that? Because then we don't want to be able to just proceed with an empty key. We need a key for those. I mean, it's an obvious solution. We literally just need to make it so that each cipher is responsible for its own key. So for example, our keyboard shift cipher service does now grab a key because it used a key. It had a seed to determine how many times it shifts. Is that right? No. That's right. It had a key that was used to seed the random that would determine whether or not it shifts left or right. That's right. And the reason we needed that as a key was so that when we passed in that random, that 4-digit key, it would make sure that the random was identical and thus would shift left and right appropriately. So you get the same pattern of left and right for both the decrypt and encrypt. And then the amount of shakes is something that gets passed through. It's another question that gets asked. Please enter how many, the amount of shakes. So, yeah. That's for the keyboard shift cipher. But like I said, the @bash one is super simple. It doesn't use a key. So if I go down here, it doesn't even get any parameters. It's so simple. There's no parameters. It's literally as simple as, you know, we're going to on our console window in the encrypt, enter a message to be encrypted. Bosh, great. If you pass in an empty string, it will say error encrypting. If you don't pass in an empty string, it will then create a set of parameters. It will then try and populate those parameters with the cipher's own get encryption parameters, which here is just empty, so it doesn't actually get parameters. And then it'll encrypt it. It really is as simple as that. Yeah, and then outputs the encryption details. We do still, as part of the parameters, we do actually still make use of a key. Hang on a sec. Sorry, not the parameters. As part of the return, so when we get the encryption back, we do still have a key property. It's a nullable string, which just means by default it's null. It can be null, and it is null by default, I believe. I mean, either way, even if it's an empty string, what happens is we've got this if string not null or empty. This is null or empty. We do a not check on that, so we check to see if it's not null or empty, and then if it's not, then we print it out. Otherwise, we don't bother, because why would you print out an empty key, you know? And it's the same with on the decrypt. We do the exact same thing down here. Current decrypt.key is null or empty, and we just do a little not check. So yeah, that's part of the changes I have made. I have actually also improved this to the point where literally we know bunker project. This bunker project here on the right is our command prompt. If I go into the dependencies, like the references essentially, before in the projects we had our book cipher service and our keyboard shift cipher service, and we were loading our list. So this list here of our ciphers, originally we had this sort of like be a list, and we had like, you know, new book cipher service and new keyboard shift cipher service. We're not doing that anymore. No, I made it so much better. Now if I go into projects, the only reference is the API, right? because the way it loads, and I'll show you, if I run this, run bunker project, it does still now load all of these ciphers, even though they aren't referenced in here anywhere. So if we go to switch cipher, you can see these 5 ciphers. Where are they? Where are they coming from? You know, if I expand this, like you've got this properties folder, but I mean that's just our published profiles we created before. All they're responsible for is publishing this program, this command prompt window. They don't actually hold any code, as opposed to, like in regards to the ciphers. You know, we've got this model, which is this is our console command. We recognize this, yeah, okay. We've got program, which is our command prompt window, and sure, we've got, you know, cipher path, we've got commands, we've got ciphers list, and we've got the iCipher service active cipher. We had this as well. We've got our encrypt and decrypt. We've got this load ciphers, which is new, which I'll get to in a sec. And we've got this initialize, which I think isn't new. I think we had that before. That was used to initialize which the cipher that was loaded when you used the second command, or well, the third command, switch cipher. Anyway, and then we just got our loop, basically, our main loop. So please press the corresponding key to perform an action. It would list out the commands. Please enter a command ID to run the function. You type your key. You know, yeah, you'd type it. It would then try and find that command. If the command is null or it's a reload, then continue. Otherwise, if it's exit, break out of the while loop. And then you handle command, which is what we had before, right? I think this logic is slightly different in that I don't think we had this else action invoke. I think I had that. This had some sort of logic in there to handle. Okay, is it you know, is it switch cipher? Is it encrypt? Is it decrypt? Those have now been broken out. So if I go into initialize, we've now got yeah. So all of the commands now have actions associated. So the exit command has this action, which we were doing this before with our ciphers themselves. I've now expanded it to then it uses these actions in the built-in command prompt window now. So yeah, exit is just an environment.exit. Easy stuff. Switch cipher, it uses this switch cipher code here. So when you use command 2, it will run switch cipher, which is this. This is exactly the same as we left it before. Lists out all the ciphers that are in the cipher list. You just type in an ID that matches up, and it will try and load that one. Simple as that. Did we? Yeah, I think we did this last time, where we added the logic in to make sure that you don't type in a number greater than the amount of ciphers, and I should probably have that be. Hang on a sec. Or cipher ID is less than 0. My bad. I didn't take that into account. So if you typed like a -1, it would have crashed. Anyway, that's that's fine. So this is the same, and this is where our initializer is called. So that's happy. That's happy days. You got the encrypt and decrypt again. It's just the same logic as before. But then I alluded to this switch ciphers because nowhere else in this does it even mention our cipher specifically. Like, how does it know to? How does it know what our 5 ciphers are? Well, it's because of this lovely thing called reflection. So what I'm doing is we've got this cipher path property, right? This here. I guess it's not really a property. It's a variable. Anyway, cipher path variable, and it's equal to the base directory of the current application being run. So the application, the command prompt being run, we can get the base directory that it's being run from, and that's what our cipher path is. Okay, so for example, if I come here and go over here, so this folder here that you see, this is our base directory right now, and we've got all these like ciphers here. We've got, you know, @bash book, Caesar cipher, keyboard shift, and this Wolseley cipher. I'll go through what some of these do in a minute, but we've got these 5 ciphers, right? How does it know to load them? Well, what we do is I grab all of the files within the directory, within the base directory, and then what I say, right, for each file within those files, the end where the file name, so X is substituted here for file name, so the direct, like the path, the file path, each individual file path, where it ends with cypherservice.dll. So these ones here, these 5 I've got selected, they end with cypherservice.dll, right? That's how our code knows which one the ciphers are. And then basically for each of those files that matches that, so our 5 ciphers, I then get the file name. So this is the file name without the DLL part, basically. So for example, it would be specifically book cipher service, @bash cipher service, etc, etc. We then try and load the assembly. So that's what those DLLs are called. They're assemblies. They're assembly files, and we load it as an assembly. I'm going to be honest, something I'm going to put here is if assembly. Actually, I'm pretty sure I did this. Did I do this? Yeah, okay, we're going to get this thing that says expression is always false. It's weird. For some reason, it assumes that it will never be null. Either way, fine. We grab the assembly, and then I've got this var args equals new list object question mark, new list of type object question mark, and then we've got this null and command.count. Now, if you remember back, if I open up this keyboard shift cipher service, if you remember back to when we were making an instance of our keyboard shift cipher service within our ciphers list, we were doing like new keyboard shifts cipher service, and then in the brackets we were doing this command index colon 0. Command index colon commands.count. That's what we were doing. So in order to load our cipher services, our DLL or assembly files, we essentially need to tell our code what to pass into here when it loads it. Now, I haven't tested this. I don't know if I could have just done command index. But the thing is, because it's expecting an array of parameters, I don't know if I can use like named parameters. I don't know if that's going to work. Like how we were doing it before, we were naming command index specifically. We were passing that parameter in by name, which is why we could skip the seed part. Anyway, just to be safe, instead now we pass in null for the seed, because we always want it to be random. Like we've not come across any scenario yet where we actually want to pass in a seed, right? I can change that if needs be, but for now it's fine. And then our second argument is the command.count, which is fine. That's what we want to do. And because we know that only one cipher can be loaded at any one time, it is absolutely fine if all of our ciphers have their commands start from the same index, because no 2 ciphers will load at the same time. No 2 ciphers will show commands at the same time. So even though we might have 4 ciphers that all have commands that start at index 4, only one of them's going to be in the list at a time. So we can just assume that we can pass in the current command.count, right? So that's our list of arguments, and it's the reason it's object question mark is because of the way this reflection works. It doesn't know what we're looking at. It doesn't know what the assembly's inner workings are. So you just have to pass in a list of objects, and then the assembly itself will convert and do what it needs to do, right? It will recognize this as an integer when it loads this. Oh god. Okay, I've opened up. I didn't want to do that. It'll recognize that command.count as an integer when it loads this part, right? Simple as that. We don't have to worry about that. And then, yeah, we create this object, which is equal to a new instance, essentially. We're creating a new instance of our assembly. So essentially, this is where we're actually now calling our DLL file in. Like, we're pulling it in and actually making use of it. And specifically, we're creating an instance of a class, right? So before, we were doing new keyboard shift cipher service, right? So new keyboard shift cipher service. Well, that's basically what we're doing here. This object, this object, is essentially like its value will be equal to new keyboard shift cipher service effectively. And actually, it is. When it gets pulled in, it is 100% that. Like, it is legitimately of type keyboard shift cipher service, and it's freaky how it knows that. Like, you know, if I put a breakpoint in here, which we could do. When I load it, I'm pretty sure it'll load up the @bash one first, and it'll load up as an @bash cipher service, even though there is absolutely zero references to that in this code. Like, it's so cool. But anyway, what we're doing is we're creating an instance of it. We're having to do a file name dot file name. So like I said before, file name for the first one is @bash cipher service, and the reason we have to do @bash cipher service dot @bash cipher service is because we have to reference the class within the assembly, within the namespace. So for example, if I come over here to the @bash cipher service, this is the class @bash cipher service within the namespace @bash cipher service. So essentially it's namespace dot class. That's how we see this. So it's namespace dot class. And to keep things simple, the namespace matches. The class file is the name of the project, just for simplicity's sake, and because then it also matches the file name. So simple as that. Ignore case true. I've done that just as a safety sort of like. That could probably be false, and I think by default it is false, but I just wanted to be safe. I wanted to make sure it was going to grab it regardless of whether or not I had a capital S or not a capital S or whatever, you know. Binding attributes, create instance. So I'm going to be honest, I'm not 100% sure on that one. Course constructor message. Oh, okay. I think this is basically just saying it's trying to find a constructor that matches attributes. Is that something like that? I'm guessing. Bind and null, I left it null because it's nullable. args.toArray, so this is where we pass in our arguments and turn them into an array. Culture null because I just want to put it in. There's no like culture specific code in there at all. I don't know, you know, I don't want to mess with that. Activation attributes, I have no idea what that does. I think by that point I just set it as null and thought screw it. Anyway, but yeah, the result of obj will be, the result of this will be obj, which is our actual cipher service class. So this here of cipher service, of interface cipher service, right? And then from that point, it really is just as simple as saying, okay, well, as long as the object isn't null, we pulled in the valid cipher service, because I mean this all matched up. We just add it to our ciphers as we would have done before. Bosh, simple as that. Boom. And then, assuming we were able to load at least one, we then set our active cipher to be equal to the first index of it. If not, then failed to load, because we don't want to proceed if we can't load any ciphers. What's the point in running a cipher software if you've got no ciphers? So failed to load any ciphers, press any key to close, and then it waits for a key press and then exits. Bosh. So if I run this, it should instantly, yep, here we go. So here we go, here we look. Oh, okay, this happens. My Visual Studio's freezing up a bit. There we go. Yeah, I know. But yeah, the hover over object. Look, it's weird. It's like it recognizes it as an @bash cipher service. It's weird. Okay, so it is doing some sort of like reflection thing, because you can tell it's not like. Okay, I think it has registered it as an object, but it still recognizes it. Like, you know, you got this L case reverse, U case reverse. Around. Hang on a sec. What do I normally have in the @bash? Okay, for some reason it's only showing us the read onlys, but it's whatever. It's working. It's working. So if I remove that and just hit continue, like, and I go to switch cipher, you can see it's all loaded. You've got the @bash, the book, the Caesar, keyboard shift, and Wolseley. Anyway, let me go through what these do. So let's do the @bash first. So if I go 3 and I just do ABC, you get ZYX, right? And then if I decrypt from that and I do ZYX, you get ABC. Simple as that. It's the simplest cipher in the world. It's amazing. Let's move on to let's do a complete, let's flip, let's reverse and go back down to 4 to the Wolseley one. Here we go. If I now do an encrypt and type in ABC, but this one needs a key. So the key I'm gonna do POAB. Sure. Well, I now get XWV. So what's happening here? Because Wolseley is exactly the same as @bash. One small difference. The key gets put in at the beginning of the alphabet, and then the rest of the alphabet's added onto the end with missing those letters. So we have P, O, A, B, and then it'll be C, D, E, F, G, X, Y, E, F, G, H, I, J, K, L, M, N, Q, R, S, T, you know, missing out P and O. So that's how that works. And then the reverse is the same. So X, V, X, W, V, X, W, V, X, W, V, and then Hobe. ABC. Simple as that. And then you've got the Caesar cipher, which is a nice simple shifting cipher. It's just unlike our keyboard shift cipher. It doesn't randomly shift left and right. It's a one or the other, and it's always, well, there is a shake. There is actually a shake. So if I say ABC and I go shift right Y, how many times should the text shift? Let's say 7. So we get H, I, J, and we get a key. We don't really need the key because the key basically runs you through how to decrypt it. So it's L instead of R because we're shifting left to decrypt, and we shift left 7 times. So H, I, J. So H, I, J, H, I, J. Let's not do a key. So this one actually asks if you don't have a key. Because we don't have a key, I now need to tell it that we're going to shift left. So I'm going to type N to shift left. 7. We get ABC. Right, and it gives us a key that can be used to re-encrypt basically. So that's the Caesar one, and then the book and the keyboard shift. We know those. So happy days. Okay, I think now it's time to actually start writing more ciphers. Anyway, Darts Gamer, hey, how you doing? How are things? I'm gonna hydrate for you. Dankeschön. Right. Cool. I am just gonna, just in case he's interested, I'm gonna give Streamsmister just a heads up. There we go. Cool, cool. Anyway, yeah, a little bit of reflection. Oh, it was good fun. But yeah, I'd say we now build a new cipher. So I've actually got a lovely list of ciphers. Why do I still have this open? Apparently I've still got the Wolseley cipher up. Oh, I've just realised we're going to get into some really hard... Oh, we're going to get into some really hard ciphers soon. We've got like 3 ciphers that are... Well, we've got one cipher that's really easy. It's exactly the same as what we've been doing so far. It's just, kind of. Basically, it's similar to the @bash one, which flips the alphabet. But instead of flipping the alphabet, you just associate each letter with a number. Yeah, so you literally just associate each letter with a number, and then from there, yeah, from there you can. Just trying to think why. I don't know what I'm going. What's going on? Anyway, yeah. So you associate each number with a letter, and it's a substitution. When I was saying it's like @bash, it's because it's substitution. In that it's like a 1-to-1. You know, there's no shifting or anything. It's just 1-to-1. You know, real simple. We don't need to worry about a key. So it's a real simple one. We can actually, I think, yeah, we can use the @bash one as a essentially a template, shall we say? Yeah. Anyway, I'm going to make a new project. Here we go. It's going to be a class library, and so my naming convention for these ciphers has been the name of the cipher. So A1Z26 is what this one's called. And then cypher service. The cypher service part's pretty important because our code is specifically looking for cypher service. So we're going to do that. Yep, .NET 6.0. Right, let's rename this class to A1Z26 cypher service. There we go. Cool. Hey, Strangesmiths, how you doing? Here's a hydrate for you. I was a bit late with Darks Gamer because I literally not long ago had a drink for Darks Gamer. Even though it was like 10 minutes ago he redeemed it. My bad. Anyway, we've got our A1Z26 cypher service. We need to make sure it inherits from iCypher service. It's going to give us errors. Yeah, we need to add a reference to our API. I'm going to implement all of our members. So here we go. We're all good. I'm happy for this to not have any queries. So new. There we go. This isn't going to need any console commands. This isn't going to have any action commands. It's also not going to have any encryption parameters, and it's also not going to have any decryption parameters. This then just needs to return query.select query. There we go. And all that's left to worry about is encrypt and decrypt. Simple as that. Love the simple ciphers. I'm going to come up here. And we're actually going to make use of this here. So, ooh. I just realized, so I'm going to be honest, I've been making some of these ciphers a little bit more complicated than they actually are. For example, the @bash cipher, I've got this U case and L case because I want to be able to support uppercase and lowercase without just making everything like uppercase or everything lowercase. By default, the @bash cipher service and the Wolseley cipher service and the Caesar cipher service, well, the ciphers behind them, the actual original @bash, Wolseley and Caesar ciphers, they don't do this. They don't take into account capitals. It's just you just shift the letters, you just reverse them, and there's none of this taken into account. Uppercase, lowercase. So I've been making them a little bit more complicated than they need to be. And it's going to be the same with this. And the problem is that, typically speaking, you support the characters A to Z using numbers 1 to 26. Typically speaking, spaces are 0. And I mean, with all of these other ones, the @bash, the Wolseley, the Caesar one, because we're using the letters themselves as the code back, as in you encrypt text with text. Simple, right? Nice and easy. If we're encrypting with uppercase, if the source is an uppercase letter, we provide back an uppercase letter, right? If the source is a lowercase letter, we pass back a lowercase letter back, right? You know, after encryption. Problem with A1Z26 is because we're passing back numbers, you don't have uppercase and lowercase numbers. How are we going to represent uppercase and lowercase separately? Now, we could... So, let me just show you the format of how this is normally returned. So, normally when you encrypt, you get your code back as something like 1-16-22-9-3, etc., etc. So, that they typically... I mean, typically you would write out your code with some sort of spacing in between. Otherwise, at the end of the day, if you don't, how are you going to be able to distinguish from 1-16 or 11-6, right? You know, how are you going to be able to distinguish from... okay, well, I mean, 22... I mean, that's got to be a 22, because you can't have 29. You can't have 29, can you? You can't have 62. But then how do you distinguish from 22, between 22 and then 2, right? Do you see what I'm saying? So these are some of the problems that come by if you don't like separate your letters out, basically. So because of that, we know they're going to be spaced apart anyway. So what I'm thinking is we replace the dash with either a U or an L. So it will become something like U3 L A L 22 L 14L9, and then it'll be like you know, L0 for space. Let's just assume no, we're going to treat space as like lowercase, I guess. Space would be like L0, and then it'll be like U7 L2 dash, and then that would indicate, because the dash won't be translated, the dash would be non-encrypted, and then like U1 L9, you know, etc, etc. That'll be our code basically. So U and L will be used to determine whether or not it's uppercase or lowercase, which is just, it does complicate things a bit, but it's whatever, it doesn't matter. And it does of course mean that it makes it really easy, because we just need to get the index of the letter and that's it. It's a real simple cipher, honestly, super simple. I'm just going to grab the constructor for @bash, reuse it, because why not? We can get rid of this U case and L case reverse. Yes, something I've done is in the cipher service, in the extensions, I've got this one extension class now. We had two before. I figured we might as well just have the one and just add more classes as we need be. I've got this reverse. Turns out reversing a string is, I mean, it's simple, as you can, like, it's not the hardest thing in the world, but it's not like it's just as simple as dot reverse. It is now, because I've written it, but it wasn't like this, you know. As you can see, you get a string, you have to convert it into a character array, you then reverse the array and then turn the array back into a string. You know, I did try doing a link reverse, a link query, a reverse link query, which did give me a reverse array. Like, it basically matches that. There's this array.reverse, that's basically a link query. Yeah, I mean, this specifically isn't a link query, but you can do a link query on a string which does this basically. It will return a reversed character array, and it was just, then it would have been as simple as doing this, but I just figured it's easier to write a reverse method. Why not? Because then I can just do things like, you know, this string is equal to this string dot reverse, and it works. It's great. And then the Boolean things, that's the same, and these base 64 and encode and decode are the same. We don't have to worry about those. Right, so here we go. So we've got our A1Z26 cipher service, and we've got the constructor set up. We're checking U case and L case for errors. We're printing the errors out, well, rather we're throwing in an exception if there are errors, which is great. We want exceptions. We don't want this to run, because it'll be an invalid encryption and decryption if we let it run, as we found out, where it was the other day when it was giving us, when we accidentally had $2 in our keyboard shift cipher service, and LP suggested, hey, delete the $, and I did, and it was still in the encryption. I was like, whoa. What? Because that shouldn't be there, and it turns out it's because it was duplicated, like 4 characters, 2 characters back, sorry. I think we literally had $2 like that. There, $2 bracket $. Oh well. Anyway, so this now checks that handles it for us. It will tell us what characters are duplicated. So that's good. Right. So yeah, so here we've got this. I could, in theory, make this one long string and use modulo, I think. Yeah, I could do like index of modulo 26, but yeah, let's give it a go. Let's try it, because if it works, yeah, if this works, then I can probably refactor. I can probably, like, yeah, go through a bunch of these other ones here and tweak it. Just wondering how I'd go about doing it for this one, because this, you know, the A1Z26 is real simple. It literally is just index of this character, bosh, done. @bash, it does involve like some flipping, like some, like, you know. But then, having said that, It's going to be the same in reverse anyway. So I might as well. Oh, no, it's not. No. Because, no, hang on. Yeah, no, the reverse will... What will happen is uppercase A will reverse into lowercase z, and I don't want that. We don't want that. We want to keep the case. Well, okay, I'm gonna mess with that layer. I'm gonna mess with the @bash layer. That's fine. I actually want that @bash back up again. I actually need to refer to the encrypt and decrypt. So I'm just gonna yoink the encrypt from this. Place that there. Here we go. We want to use string builder. Let's get rid of that one. Okay. So what I'm doing here, oh god. Hang on a sec, one sec. I might be able to make this even simpler than I thought I could. Hold on a second. I'll run you through what I'm doing in the sec. Index equals -1. If index is greater than or equal to 26, because yeah, because uppercase Z will be 25 because it's 0 based in index. So bar U case equals whether or not the index is greater than L case. We'll go L case. If it's lowercase, then it'll be greater than or equal to 26. And then we just want to return L case. U, otherwise L, and then we also want to return index modulo 26. In theory, this should work. So what I've done is in our for each, so in our encrypt, we've got our properties, our encryption properties. We default the output to be equal to the input. So if there's any issues whatsoever, it just pumps out what it gets in. You know, we don't bother fussing about. We just pump out what we got back in. We create a string builder to build our output from. Our new out, you know, assuming everything was successful, to build our actual output from, output on. We then loop through all of the characters in the input. This is all stuff we've done before. Super simple. Index. So this is what I've changed here. So I'm attempting to get the index right away. Before I was attempting to see if the character existed in the list. And then from there, you know, if it didn't exist, then we would just add the character, the input character back to the output, right? We would just add the input into the output, like without modifying, without encrypting it. But I mean, I don't know why I didn't bother thinking of this before. Returns a 0 based index position of value if that character is not found, or -1 if it is not. So index of, if it doesn't find the character. So for example, let's say C is an exclamation point, which isn't in our characters list here, right? There is no exclamation point in there. So if C is an exclamation point, this index of should return -1 because it doesn't exist in chars. In which case, I can just do a check to see if index is equal to -1, and if it is, just add the exclamation point onto the output, right? Because we can't encrypt it. There is one exception, and that is if C is equal to space, then output dot append L0. That's what we're going to do. Else, and then do that, and then continue. So if C is equal to an empty space, right? So just space. So if char is space, we add L0 to our output because that's what we've predetermined as to be space. typically speaking, in a regular A1 Z26 cipher, when you wouldn't be taking uppercase and lowercase into account, space would just be 0. There's no L involved or anything in the base cipher. In our version, though, we are taking uppercase and lowercase into account, so we're just going to default to lowercase space, whatever, it doesn't matter. Sure. Otherwise, if it's not a space, then we just add our character. So if it's an exclamation point, a comma, a full stop, maybe a $sign, an @ symbol, you know, whatever, just add it to our output. Simple as that. And then we continue, regardless of whether it's a space or not. We don't care if it's not in that list. Even if it's a space and we specially handled it, we still continue because we then don't want to like proceed with our logic. Okay, so then we do our check to see if the index is for a lowercase letter. If it's for a lowercase letter, we know that because index will be greater than or equal to 26. Reason we know that is because the first 26 characters are uppercase. We know that. And the reason we're saying greater than or equal to 26, even though there are 26 letters, is because A is actually 0. A is the 0th index, which tells me, actually, I'm an idiot. This... Ooh. Hang on. We might need to play with this a bit. This actually needs to be +1. Maybe. That might cause problems. But essentially, this here will tell us... No, that shouldn't. No, that should be fine. We should be fine, because at 26, that would be 0. +1, which gives us A. Okay, we should be fine. But essentially, because we know the first 26 characters are uppercase, we start at 0, so Z is uppercase Z is 25. So index 26 is A, and above are all lowercase, right? So that tells us if our character is lowercase. Got these wrong way around. One second. There we go. And then all I'm doing is I'm adding to our output. We're just adding this interpolated string. The result of the interpolated string is, first of all, check to see if L case. So L case is a boolean. If L case, then we use L. Otherwise U, in which case we assume it's uppercase, right? If L case is false, it means the index is less than 26, which means it's uppercase. So that's the first half of our interpolated string. The second half of our interpolated string is then the result of index modulo 26. What that means is we divide by 26 and get the remainder. The remainder. So, for example, if we do 24 divided by 26, the remainder of that is should be 24. This should return 24, I believe. Whereas if we say, for example, 26 divided by 26, we get 0. The remainder would be 0, right? We could do, you know, 27 modulo 26. Yeah, 27 modulo 26 should return 1. We know 27 is lowercase b, but lowercase b isn't 1, so we've got a little +1 to handle the, like, the viewing, the friendly viewing of it, because, like, you know, as a non-techie, you wouldn't just assume A is 0. So we add 1 to make it easier to understand. Anyway, in theory, this should be working. This should be fine. So then all I need to do, in order to decrypt, I'm copying the encryption because it's going to be similar. How are we going to do this? This is going to be tricky because we can't just trim it we can't just say, right, get us every 2 characters, because once you get past character 9, it becomes character 10, in which case it's 3 characters, right? Like, you know, when we're iterating through our output, I mean, I can't just say, right, well, you know, group by 2 to give us like L0, L1, U5, you know, because then you might have what's supposed to be a U15, but it becomes a U1 and then 5L. All of a sudden our entire string is just, you know, foobarred, which is no good. And we can't just split by L, because then that just won't work. We might have to make use of regex. This might become a lot more complicated than I wanted it to. But we might have to split by regex, where we split by L or U. which would be fine. Like, that's cool. It's just... it's a little bit more complicated than I wanted it to be. Regex. Well, C#. Regex split. Multiple delimiters, that's the one. So you can split by multiple delimiters, so... oh! Wait. Oh, never mind. Ignore me. I'm being an idiot. It turns out the default string.split happens to support multiple delimiters. That's awesome. W Gaffer. Gaffer? Hey, how you doing? Working on ciphers. We're making something that will encrypt and decrypt stuff. We're currently working on an A1Z26 cipher at the minute. We've got the encryption sorted. We just now need to have it so that it decrypts. So that's what we're working on at the minute. Okay, so can't use chars. Yeah, we can. Chars. Input chars equals parameters.input.split, and apparently, yeah, we can pass in multiple characters. Love it. Okay, well, L. There we go. We split by. I think part of this is I can. Yeah. Okay. Wait. Would that work? Apparently that works. So this should, in theory, trying to think of how we can end up keeping the U and the L, because we do need to keep those. Is this gonna work? I know there's a way of like having it keep. Hang on a sec. No. Okay, C# split, string split, keep delimiter. Keep those delimiters in the results. Oh, well, that's this is where we might have to start using regex. Okay. Okay, apparently there's a way of... Can we do that? I might have another extension method. Let's have a look. Let's try this. Let's try this. Where is it? So within the string class, we've got this. So let's see. So we've got the split and keep. it returns an IEnumerable of type string. That's fine. We've got our input string. That's great. So start equals 0 and index. Okay, I don't like making my variables this way, but sure, we'll roll with it. While index equals s.index of any delim start. Okay, so while basically index is not equal to -1, that makes sense. Okay, that's fine. If index negative start is greater than 0, you'll return s.substring start index negative start. Okay. Right. Otherwise, you'll return s.substring index linked one. Okay. I keep having to remember it's an enumerable. I'm thinking, wait, if we're returning, like, how are we going to get more out of it? It's a yield return. Yield return just means that it will return this thing, but then on the next iteration through, it will, like, return the next, essentially. It will keep going. So if this is true, then it will return this. But because it's an IEnumerable, you can enumerate through it, which just means that it remembers where it was last time it left off, and yeah, it basically means that when we try and get the next item, the next like the next substring, basically the next split bit, we say, okay, well, where were we before, right? Okay, well, you know, blah blah blah, you know, yield return that start equals index plus 1. Okay, I know, I see what's going on. Okay. I was going to say this. This is a bit dangerous. Doesn't this just assume that your delimiters of like length 1? What if your delimiter is like 3 letters long or something? But I realised we're passing in a character array, so of course it's going to be of length 1. So that makes sense. That's fine. Start equals index plus 1. Okay, that's great. So this is telling me that for each iteration through, we're attempting to obtain the bit without the delimiter, this, and then our second, like the next object in the enumerable, the return, whatever it is, the list back or whatever, will then be our delimiter, right? And then we set our start to be equal to index plus 1. So then on the next loop, we then start further along, right? We skipped a bit we've already handled, and we're now starting from here. I don't know if I'm doing that in reverse. I don't know which way I'm, like, I remember I flipped my camera, but it's whatever. And then once all that's handled, if start is less than s.length. Okay, yeah, and then basically this handles the very final bit. So if you get through all of that, we know that start should be essentially the last point at which, like, once you've left this while loop, we know that start is now equal to the index in the string, the next index in the string after the last delimiter, right? What we're saying now is essentially if start is less than the length of the string, so we know there is more in the string, because, you know, we know that start is now the next index after the final delimiter. We know there's this last bit here that doesn't have any delimiter within it, but we still want to return that at the end, right? So then you just do a yield return substring. Yeah, it's that simple. I like it. Cool. So in that case, all I need to do is dot split and keep. We don't need to worry about the string options. Okay, this time, unfortunately, I do actually need to create a new array, just because the split and keep doesn't have the functionality for the params. Let me have a quick look, actually. Dot split. Oh, why am I mistyping? What am I doing? What am I doing? Jesus Christ. Let me just have a quick look. Let's just have a look at how this handles it. Yeah, params char. Okay. We're going to copy that because I want to make use of that. Let's call this separators. Yeah, that's clever. Yeah. What I'll do here is just thinking about how we can do this. If okay, that can be pattern matched. Let me handle all this. Yield return S. Okay, cool. Sure. That can now be set to var. Right, there we go. So all I've done is we've now got this params sort of thing set up so that we can do this fancy dangled. Get rid of that. We can now do this fan angled thing where we just basically add on all the characters we want, right? As if they're different parameters. Love that. I think that's great. So that got that sorted. And all I did here was, like I said, we changed it so that it's not just like a char array, it's now params char array, which is what allows us to do the add it on as if like it's unlimited parameters. And then all I've done is because we're passing it in as a nullable. I'm guessing, why are we doing that? Why are we? Oh, I know why. Because we're doing a split and keep, and the reason it's nullable is because with the normal split command, you don't have the normal split method. You don't have to pass anything. You can leave it null. You can leave it like blank. You leave the brackets blank. And essentially, what that means is, like, if we go to our string manipulation, okay, I mean it doesn't have a default of null. I'm guessing there might be another split somewhere that has a, I don't know, I'm not sure where it would be, but long story short, I think the reason it was nullable was because it could be null and you wouldn't pass any delimiters, in which case it would split by each character, so you would basically get an array where each element is of length, like string element is of length 1, and it's each individual character has its own element in an array. That simple. We don't want to do that. If we wanted to do that, we would just do a dot split, right? Simple as that. However, that means I can actually just reverse some of what I've done, I think. Yeah, okay. I need to do it in there. Yeah, okay. We're all good. You know, I was worried I would run into problems there, but we're all golden. Oh, why does this something spring thing? Oh, it can be. I thought it was going to say, oh, I can make it simpler by using something else, but no. What about this one? Yeah, range index. I thought it would be. We're going to use that. Cool. Okay, you don't have to worry about what I just did. I basically just replaced a substring using this range indexer, basically, because strings are essentially arrays. You can treat them like arrays, and we're just saying, right, return everything in S, which is after start, and then you've got the, I forget what these are. I learnt about them in Python. I never learnt what they were in C#. I think they're the same, but it's whatever. I don't care. We know it works. Anyway, back to our cipher. We need to now decrypt this. We want to loop through input chars. Yes, we want to loop through input chars. And now, in theory, we should have something like U6, L15, L4, U22, in theory. the only way of knowing for sure is by doing var split character equals c dot split, and this time we are no, not split. Actually, yeah, no, so we can do substring 0 1, and yeah, it's going to tell me to use the range indexing. Yeah, there we go. I think this basically just means get everything up until the first character. Well, up until element 1, basically. I feel like the middle one's like skip. I'm not sure. I'm not too sure. Oh, stream smith, are we hydrating, are we? I was just thinking I need a drink. Dankeschön. Am I making any sense, by the way, stream smith? Like, is anything I'm saying makes, or am I just rambling? I might just be rambling. We'll see. If split character dot equals, so this is our first character. This is the U or the L. Been in and out today. Oh, fair enough, fair enough. No worries. Okay. How are you doing then? How are things? How you doing? If the split character is equal to U, and we want to do like a ignore case, because we want to, we don't care whether it's an uppercase U or a lowercase u. If someone's just typed in U23 and they haven't done a capital U, we don't care. We want to handle it the same. And do you know what? Actually, I just realised this needs to be a bool. So bool U case equals that, but not really. Psych. This, oh god, this actually needs to be L case, because I've just realised the uppercase are the first letters, which makes handling those easy. We need just the lowercase ones we need to handle. So L case is equal to whether or not the first character in our split, yeah, in whether the first character in the split of our already split string is L. If it's L, then it's lowercase. If it's not, we just assume it's uppercase. It could be R, it could be T, it could be M. We wouldn't care, basically. Oh, something that's just occurred to me. This is oh no. I just realised this is going to cause problems for if we happen to try and like encrypt symbols and stuff. Okay, what we're going to do, well, I'm going to just ever so slightly modify what we do when we find a character that doesn't match. We're actually going to use the same thing as we're doing for the space. Oh god, go away. With the L, so we're just going to say, right, just assume it's a lowercase @ a lowercase quote, lowercase $sign, lowercase, you know, slash, lowercase dot, lowercase exclamation point, whatever. We're just going to say L, because that way it then handles the split. It'll gracefully split. So we're all good there. That should at least fix things. Right, then what we do is if well, var remainder is a bad word, var index equals split character dot substring from 1 onwards, and it's yeah, it's gonna I have a feeling it'll do this. Cool, that's fine. So basically what we're doing is the index is equal to essentially the rest of our split C, my bad. So index is equal to the rest of C, basically the bit that we didn't pick up was split character. So split character is the first letter in our C, C being each individual split of our input, where that split is by U or L. So split character should be either a U or an L. If it's an L, we assume lowercase, and then what we do is we try and get the index, which is a string still, from the rest of C. So this C would be, for example, U22. So split character would be U, and index would be 22. We now need to do if int.tryparse index out var, oh, not out var char index. Then what we do is output, no, not out of memory, output dot append okay, so if L case, then char index is equal to char index modulo 26. Oh shoot, I also just realized char index negative, right, because I forgot we were for right, I forgot a in our code is 1. We want it to be 0, so we first of all decrement the value by 1, so we take 1 off, which is what that negative does, and then what we do is we say, right, give us the modulo 26 value like of it, which I think can be simplified, can't it? I think that can be simplified. Hang on. Oh god. I think you can just do this. I think you can just do char index modulo equals 26, and it'll give you the result of it. No, wait, hang on a sec. Hang on. No, what am I doing? It's plus equals 26. Yeah. Of course it is. We want to bypass the first 26 characters. You idiot. My bad. Okay. Yes, we want to bypass the first 26 characters. My bad. Okay, we're all good. We're all good. Okay, that's that. And then all we need to do is it's equal to chars. There we go. So what we're saying here is if we're able to convert the index to remainder of our U26, so after taking out the U part, the 22, U22, after taking out the U part and we have 22, if we can convert it into an integer, which we can with 22, then we take 1 off of it, so make it 21, because A is actually 0 in our code, even though we've given them a 1 as the code. We want to decrease it by 1. And then we say, okay, well, if lowercase, so essentially if it's an L instead of a U, then we need to add 26 onto our index, because we know that an L22 is actually a 48? Yeah, 48. Kind of, yeah. Basically. Well, it's a 47 because we're taking 1 off, but it's whatever. Like, we know that it's like over here instead of here, right? So we just need to handle that. And then all we do is we just add to our output the matching index in our characters array. Yeah, that's it. We just basically get the character out of the character array. The issue though is when we do an else, because I mean, actually, it's not an issue in the slightest. First of all, else if index equals 0. Actually, no, I am wrong. Sorry, it is a real simple. Once we get to this point, first thing we need to do though is if char index is equal to 0. Because that's our space, right? Our space we coded as a 0, even though we know 0 is A. In our output, we had space be equal to 0, right? L0. In the event char index is equal to 0, before we take 1 off, we need to do an output.append space. And then we actually need to do, oh god, wrong button. We then need to do a continue. Like that, because we don't then want to proceed through this, because there's no point. Right, why is this, what's it doing? For some reason the IntelliCode, or whatever it's called, the IntelliSense, is suggesting that I add a $sign to the beginning of this for string interpolation, even though I have no interest in interpolating interpolating the string, just because I use string interpolation so much. I use all over the place. It's ridiculous. Anyway, like I was saying, this else statement is actually really simple. It really is just as simple as output.append index. Essentially, if we can't convert index into an integer, we must assume it's a symbol or some other character that couldn't get converted, in which case we just add it. We just add whatever it is to our output. And that is it. That is that simple. We have made our new cipher. So let's build that and let's see if it works. So I am just going to copy it. So if I go over to here, we go to bin debug net 6.0, that file there. I'm also going to copy the cypher service API because they did update that. And I'm just going to copy it into our base directory that I was talking about earlier for the bunker project. I'm going to replace cypher service because we added a, oh god, there we go. We did make changes to the extensions. We added in this split and keep. So that's cool. Yeah, and then let's just run it. If I now go to switch cipher, our first one is the A1Z26. So if I go encrypt and I say test in all caps, we get U20, U5, U19, U20. Okay. Let's copy that into a notepad document. Let's also make this a bit bigger. Right, let's decrypt. So U20, U5, U19, U20. Oh, okay. Ha. Hold on a minute. Oh. Now, one great thing about this is because we have everything loaded in here in our Visual Studio window, even though we're loading these modules through reflection, we can actually hook into it. So if I happen to put a breakpoint in our A1Z26 cipher, right, and I do a decrypt, and we paste in what we copied, hit enter, we can actually step through it, right? So if I do an F11, okay, that's not what I was hoping to do. What is input chars? Right, hang on a sec. So what is C? C is U. Oh, right. Of course. My bad entirely. Wow. Of course, I'm such an idiot. This is set up so that it returns the delimiter as a separate. Yes, okay. Yes, so this pulls in this gives us the delimiter separately, basically. That's all it is. Just gives us the delimiter separately, which means that we won't get a U22, we'll get U22, U5, L2, L15, and that's fine. All we need to do is change our for loop. So for I equals 0, I is less than input chars dot. I'm going to change this to a to list. Just makes it easier to control here. So count, and then we do I plus equals 2. I don't think I've ever done for loops on stream before that does this. Basically, we've got this character I, so we've seen for loops before, right? Normally, a for loop we would do is this. So let me just get some code in there. There we go. Right, so you can see it properly. So normally this would be a for loop. This is what we'd normally do. For var I equals 0, we set up our variable I, set it to be 0 at the beginning, and then we're going to loop through for as long as I is less than the count of our input characters, and then at the end of each loop we're going to increment I by 1. That's what the I++ does. It says at the end of each loop, increase by 1. That's how we do it. But we're not going to do that. This time we're going to do I plus equals 2, which means at the end of each loop we increase by 2. And the reason we're doing that, what I'm going to do is I'm just going to grab all of this code here, We're going to stick it inside our new for each, and we're going to modify it slightly. So now, instead of saying our split character C, split character is going to be equal to the first index of C, which we thought was going to be U in U22, we're actually going to do input chars I, which would be U, and then index is now going to be this is going to be input chars I plus 1, which is going to be our odd number character, which is going to be the 22. It's going to be the 5. It's going to be the 2. It's going to be the 4. It's going to be 16. Cool. One thing I'm just going to do is I'm going to replace split character with case char. Case char. And then we're going to do this with char index. Oh, never mind. No, we're not going to do that. We're just going to call it index. Because that was going to mess with that, but it's fine. Anyway, that should, in theory, work. If I now build this, let me come back over here, and we're going to copy this in here. Yep. Okay, let's run it. Right, so we want to do decrypt, and I should just be able to copy this from here. I'm going to copy by hand because I want to do the lowercase, U5, U19.U20. Right, index was out of range. It must be non-negative. Okay, that's fine. Okay, that's because it's splitting by capital U and L. That's fine. Okay, I was hoping I wouldn't have to do this. I was hoping it would just gracefully work. There we go. So we're now having to also split by lowercase u and lowercase l. Whatever, that's fine. It's fine. No, I can't just run it. Hang on one sec. I have to actually build, and at some point I'm going to have to get a script created that will copy the value, copy the built file. At the moment, I have to manually copy it over. Okay, so decrypt U20, U5, U19, U20. Test, there we go. It didn't breakpoint. Did I remove the breakpoint? I might have done. I did. It worked anyway. Whatever. Don't care. Now I want to try... no, I was going to try an odd numbered word, but it doesn't really matter. Well, I mean, we do need to still try this. LP is best. Here we go. We've now got some fancy stuff going on. So if I now decrypt, paste that in, and then decrypt as LP is best. Let's do another encrypt. LP is the best, exclamation point, dash, can you believe it? Question mark. It looks like it's handled that. Or decrypt that. LP is the best, can you believe it? Yeah, it seems to have worked. Fair enough. I'm going to assume that's worked. Happy days. Yeah, let's not save that. And there we go. We've got a new cypher in. That took longer than I was hoping it would. I'm going to be honest with you. What have we got next? Right, okay, we've got 2 ciphers we can crack now, and then I think we're going to call it for then. Next time we work on this, though... Oh, God, I'm not looking forward to that one. I mean, yeah... Actually, no, that one's an easy one. Do you know what? Yeah, no, we got 3 to do. We're gonna do 3, and actually, we're gonna I'm gonna move that one to the front. We're gonna work on a keyboard change cipher, slightly different wording from our keyboard shift cipher. Our keyboard shift cipher is responsible for taking the keyboard, mapping the keys, right? So Q all the way to P, A to L, Z to M, so horizontally, and then going down. And what it does is it shifts left and right, right? Super simple. The keyboard change cipher, on the other hand, takes the keyboard layout, right? The QWERTY keyboard, for example. Let's say you've got a message, you've typed in LP is best. You've got your QWERTY layout. And what it does is for every character in your string, it will find where that key is on the QWERTY layout, and it will then map it to a different keyboard layout. For example, AZERTY or Dvorak. Yeah, AZERTY and Dvorak are the two examples given. So QWERTY, AZERTY, and Dvorak. And so essentially then the L remains the same in AZERTY, but in Dvorak, the L is moved all the way to the other side of the keyboard, like in the string at least. Because again, much like our keyboard shift cipher, it takes the 3 lines and makes one long line. But where L is normally right at the end of the middle line, on QWERTY, on AZERTY, it's sort of towards the end, about 2/3 of the way along the top line. Sorry, in Dvorak, I don't know if I said AZERTY. In AZERTY, it's in the same place. AZERTY is identical by the looks of it, with the exception of a couple of key letters, specifically AZERTY. Yeah, I mean, there's a little bit of shuffling, but like for the most part, AZERTY and QWERTY are identical. The biggest difference is the AZ. The only differences are AZQ, M, W, and N. Well, not even, like, basically XCVBN have just been shifted down one. So you take the M out and shift CVBN along, and M goes somewhere else, basically. M goes 2 to the left of C. Like, well, 1 to the left of C with 1 in between. Sorry, no. Sorry, 1 to the left of X. Sorry, the XCVBN, you move to the left, to the right. And so where X was... Is that right? No, where Z is at the minute, there's an M and X becomes a W. Yeah, it's whatever. The keyboards are nearly identical. Point in case, like, what I'm saying is, you know, yeah. Anyway, yeah, so we're going to quickly make a keyboard change cipher. So let's do that now. So add, new project, class library, keyboard change. Can I type? Is that not a thing? Change cipher service. There we go. Want to rename this to keyboard change cipher service. Yeah, that was weird. That was a different window from normal. That normally pops up. Anyway, so this needs to implement inherit from iCipher service, and it's going to give us an error. We just need to reference the project, pull in the members, bosh, do what we did before. So this needs to be replaced with new. As is get commands, get query multiple needs to become query.select query, and then action command is just going to be a nice, oh god, nice empty encryption parameters and decryption parameters. Those are actually going to need things this time, specifically which keyboard you're changing from and which to, because we shouldn't just assume you're using QWERTY. You might type a message using QWERTY, sure, your keyboard might be a QWERTY keyboard, but you might say, actually want to convert from Dvorak to AZERTY. Yes. You might want to use Dvorak as your base keyboard for your message. Convert to AZERTY. You never know. But yeah, basically, yeah. So that's what we want to use the encryption and decryption for. So encryption will ask you which keyboard you want to start with, like essentially what keyboard your input message should be written in, and then what keyboard your output message should be written in. And then it's the same with decryption. Same questions. It's the exact same questions, basically. In which case, I'm happy to go into keyboard shift cipher service. Oh god, go into here and just copy some of these details. So Let's just take this key one. I'm going to modify that slightly. So here we want to say, please select which keyboard the input should be encrypted with. Which keyboard the input should be passed through. Yeah. Might be a bit confusing, but it's whatever. I'm going to have this be an parameter of input. Input. And then I want to repeat that. But have this one be output. Output, there we go. And then what I actually need to do is, we're not going to use a read line. This is actually going to be a read key. Input.key. Sure. Yeah, I suppose we could do that. We could handle the key separately. We could handle the key specially within our thingy. I'd rather not do that, but we can make it work, I guess. Yeah. Right. Let's start getting some stuff up here so we can actually play with. Right. So that's our QWERTY keyboard. I'm going to call it QWERTY. That is not QWERTY. QWERTY, there we go. Then we got AZERTY and Dvorak. That's the spelling, right? Yeah, that's the one. Now I just need to retype this. So AZERTY. AZERTY. UIOPQSDFGHKLMWXCVBN. Nice. And then Dvorak is completely different. PYFGC RLAOEUI EHTN SQJK X BMWVZ. Apparently I got that right. There's our Dvorak. Okay. Yeah, and then essentially this is going to work very similarly to basically our app bash, I guess, but instead of referencing to like the reverse, instead of referencing reverse, we basically just want to, it's going to be real simple. We basically just want to reference the other keyboard, basically. Right, let's pull in this here. Right, keyboard change, cypher service. Right, errors is going to be equal to QWERTY. Right, and then I'm just gonna var errors. Hang on a sec. QWERTY. Errors dot add range. I'm going to repeat this, but for AZERTY. There we go. And then we want to repeat that for Dvorak. There we go. So that then controls our checks to make sure there's no duplicate letters. I don't think there are, but we'll see when we run it. Right. So that's that sorted. We just need an encrypt and decrypt now. So let's go about grabbing some stuff, some parameters. Yeah, we want to import string builder. And then we want to do a for each input. What we now want to do though is we want to say, we want to basically grab which keyboard layout to use as our input and our output. So var input keyboard is equal to we want to do parameters dot additional parameters of index input, and we know that this is a console key. Yeah. So if this is equal to, well, first, hang on a sec. So var input param input keyboard parameter. This is going to be equal to console key parameters dot additional parameters input. We know it's not null. It shouldn't be by this point. And then all we're saying is, right, so input keyboard parameter, which I'm now actually just going to rename to IKP. If IKP is equal to Q, then QWERTY. We're going to have our input keyboard be QWERTY. Otherwise, if IKP is equal to A, then AZERTY. Otherwise, we're going to then assume Dvorak. Right? So our parameters are, oh, I think it's going to suggest using the switch. That's cool. And actually, what we're going to do is we're going to be even clever with this. We're going to actually specifically say, if D, then use Dvorak. Otherwise, null. Right? And then we're just going to say, if input keyboard, if string dot is null or empty input keyboard, then return. Simple as that. Return false. So say we failed the encryption. Happy days. Okay, and then we need to do the same but for our output. So output keyboard. There you go. Output keyboard. So OKP output. So if either of our strings are null, output keyboard. So if either of our strings are null, we return false. Right? If either of our input / output keyboards are null. Cool. So that's got that one sorted. Down here we still need to handle how to, display whether or not you should be what keyboard you should be pressing, because at the moment there's no it doesn't tell you whether you need to select Q, D, or A, and we'll get to that in a second. But first, let's just get our encryption sorted. Right, anyway, so we know by this point we've got an input and we've got an output keyboard, so it's literally going to be as simple as var index equals input keyboard dot index of C, if, and then we're going to borrow from our A1Z26 if index is less than or equal to, well, if index is less than 0, then we want to do output dot append C, and then a continue, simple as that. And then we say, so if index is not less than 0, so if we were successfully able to find the character in our input keyboard, then what we want to do is we want to do output dot append the output keyboard, the character of output keyboard that matches the character in output keyboard at index, right? Yeah. Words. There we go. That's that one. And then we basically want to do parameters dot no, hang on. Properties, that's what I want. Properties. First of all, let me pop over here. Yeah, properties dot output. There we go. Now, small issue in that It's all well and good us telling the encryptor which input and output to use, but how does that pass back to the end user? Well, we need to make use of the key. So let's do that. Let's form our key. So we want our key. Oh god, we want our key to be something along the lines of we could do IKP colon OKP, I guess. We do it like 2 strings, that thing. I don't know if that's gonna work. No, it's yeah, no. Right, what are you doing? Yeah, interpolation can be simplified. Okay, we're just going to say our key is that. Simple as that. So now the decrypt, we're going to leave that until after we've sorted this now, because we've now got encryption sorted. We just want to finish off the encryption, which is how do we format this? We could do a console.write line environment.newline available keyboards, and then we would essentially here we would do like Q where T. These don't need to be interpolated. A is 0T. Dvorak. There we go. Please enter the key that matches which keyboard the input should be passed through. There we go. Sorted. Please enter the key that matches which keyboard the output should be passed through. That might seem a bit confusing, but it's fine. And then here is we want to do a key check. We actually want to refer back to this. Just grab this. So please enter key. And then we'll say leave blank to provide details manually. There we go. And then all we need to do is if key if string.is null or empty key, then this is where we print these things out. And actually, yeah, that can be simplified by just returning after that. There we go. That can just go in here. There we go. Okay, so if the key that you provide is not null or empty, then we add it as a parameter and then we return. Otherwise, we then go ahead and say, right, well, these are the available keyboards. Please enter the key that matches which other keyboard should we press. Well, please press the key. Please press the key that matches. Yeah, we do that. I feel like that's a little bit more clear than enter. Because if we say please enter the key, it makes you think, okay, well, what you know, do I type QWERTY? I mean, you would still that would still catch it because QWERTY starts with Q, but you would like, you know, you would then type W for the output, and you wouldn't want that. So I think please press the key that matches which keyboard the input should be passed through, and I feel like this is intuitively you would assume Q colon QWERTY. You would assume that that means QWERTY, right? I think that's a safe assumption. Yeah. Anyway, so that's that. Right, now let's go ahead and get our decryption sorted. The reason I wanted to get the parameters sorted first was because we may or may not pass key through, and I needed to get that formatting sorted, basically. Right, so what we want to do is properties. Let's copy some of this over. That needs to be a decrypt properties. There we go. Bar output. Right, if so if I'm trying to think about ways of doing this. So first of all, let's just get some input and output keyboard sorted. String null. So if parameters dot additional parameters dot contains key var key is equal to that, and then we do, oh, that also needs to be a string. Cool. Var keyboards equals key dot split. How are we doing it in the minute? What are we formatting the key as? With a colon? Yeah, we do it with a colon. We'll leave it as a colon. Sure, why not? Split by colon. So then what we do is input keyboard equals, now we just need to head up here and grab this, basically, pretty much. Now we just need to basically just UAD. And I am actually just going to do a dot to uppercase here, because the key we can have that be formatted. That's fine. And then we want to repeat this, but for the output keyboard. But instead of keyboard 0, it's keyboards 1. So that's that. And then I just need to do an if input keyboard. No, we'll handle this separately. So if additional parameters dot contains key input. So if you do actually pass in the input, which you can only do by not passing in the key, if that's the case, then we handle that the same way we did before. Like this. Then the output's handled separately. If parameters dot additional parameters dot contains key output keyboard. And then after all of that, we then do another one of these checks. There we go. And then what I'm going to do is we are going to pass in we're going to have the key pass back. But for this, I just need to do input keyboard at 0. And then output keyboard at 0. I mean, we could have just done that before. Anyway, that should, in theory, work. Like, that should, like, up to this point, we should be good. Now it is literally just a matter of reversing what we did before. So I copy this and put that there, and what we do instead is we say the index of the output keyboard, and we want to get it from the we want to obtain the index of character in the output keyboard, right? And then add to our output the matching character at that index from the input keyboard. Yeah. So it's essentially the flip of what we did before. Yeah, that should in theory work. I think we should be good. Yeah, I think we should be good to build this. So this is keyboard change. I've no idea if I happen to make any changes whatsoever to the Cypher Service API, so we're going to copy it anyway. Apparently I did not actually, because it actually has the latest version of being at 19 past. Okay, cool. Right, let's run this. So switch Cypher, keyboard change Cypher Service, so 4. We want to encrypt, and we want to say LP is best available keyboard. So please press the key that matches which keyboard the input should be passed through. So I'm happy for it to be passed through QWERTY. And then I want it to be encrypted using Dvorak. Now let's copy our details. Okay, so that's given us QD. That I'm happy with that. So now we decrypt. We pass in this. We say enter the key. I'm going to give it a key. LP is best. I'm happy with that. Apparently, it's picked up P being the first letter of the Dvorak one. So sure about that one. It's really weird. Why is it giving us QP? Oh, because it is. It's my bad. Okay. I don't know why I assumed Dvorak started with Dvorak. Yeah, my bad. My bad entirely. And that is a lesson to be learned. I think what we're going to do is we're actually going to move our key setting to be in here. So this will actually then be, well, we can just do this. We can actually just make this even simpler by doing that. Basically, we're just saying, right, the returned key is just what you pass in. Alternatively, what we do is we could say var key, okay, var k is equal to string.empty, and then we bring that back again, but we just say k is equal to key. And then over here, we do k plus equals ikp colon. And then here we do k plus equals okp. And then down here, we do a properties.key is equal to k. That should fix that issue. Because we know that we either have the key or we get the input and output separately, like as in separate from the key. So it's going to be either or, like, you know. So in theory, this should work. Just need to copy keyboard cypher service over. Let's run it. So if I decrypt now and I take what I had before. Oh, what's going on? Oh, wait, what? Oh, that's my bad. I'm trying to... I mean, I should... no, it's just because I was trying to decrypt. That is entirely my bad. I was decrypting... Oh, using the wrong cipher. Switch cipher. 4. There we go. My bad. Please enter the key. Right, let's use our key. So QD. There we go. Now we're getting our QD back. That's fine. And it's decrypted fine. And let's decrypt and let's type in those details manually. So QD. Boom. Now, because this is very loose and all of the characters in one keyboard exist in the other, we could, in theory, if I go decrypt and I copy this message and I leave it blank and I say, right, well, our input so this should in theory be QWERTY, but then now I say AZERTY. Oh, something different. It is a different message. So if I now say, okay, well, for decrypt, and I paste that back in, this isn't this is still our original encryption. If I leave blank and I say, right, I actually want our message back to come back as an AZERTY, and then this one, I want it to start as Dvorak, which it was, and we now get LP as Vest. Oh, okay. So that's what the keys match up to in an AZERTY keyboard. Like if we compare QWERTY to AZERTY, I mean. So LP is best converts to LP is vest on AZERTY. And I mean, to prove that, what's going on? To prove that, I can literally just do encrypt. LP is best. Available keyboard, so we pass it in as QWERTY and provide back as AZERTY, and it's just a direct conversion from QWERTY to AZERTY. LP is vest. So yeah, okay, that's keyboard change. I'm happy with that. Something just occurred to me. What was it? I've completely forgotten. Oh yes, yeah, it's slight wording. So here, so the input. Yeah, so this I'm thinking of like slightly just basically. Right, let's just output. What it is I want to flip these around. So I know that, like, so basically from the decryption standpoint, the input is technically what we had output before, right? Yeah. Yeah, that does mean I'm gonna have to go up here and just slightly change this to be output keyboard, I think. Let's just run it and see what we get. But I want it to be worded so that from the decrypt standpoint, we should be essentially... Look, if I come over here and I go 4, no, not 4, no, 2 switch cipher, 4 to keyboard change cipher, then decrypt. I closed it. LP is best, whatever. Right, if we go to encrypt, LP is best. Oh, that's the wrong one. Hang on. Encrypt, LP is best. Right, we start with QWERTY. I want to go to Dvorak, right? We get this lovely message here, which means so much. Copy that. Right, so what I want now is if I go to decrypt, and then I say, right, so the message that we want to decrypt, this is our new input, right? Right, please press the key that matches which keyboard the input should be passed through. So this should now be Dvorak, because our input is a Dvorak keyboard, and we want it to come back as QWERTY, and that broke it. That's fine, that's fine. Okay, so this doesn't actually need flipping. Unless, no, hang on a sec. I'm being an idiot. Let's not flip those. Let's flip these. So these need to go back to being input. And output. There we go. Yeah, so now that I've done that, we should now actually have a working back and forth cipher. Give it a run. Right, 2 to switch to cipher, 4 to go to the keyboard change cipher. What I should really do is on this screen here, I should actually have it show what the current cipher is. Yeah, we might do that. 4 decrypt. That there. We want to input, so this is going to decrypt from a Dvorak to a QWERTY, and we get LP is best. Yeah, and it just reverses the key. So that then gives us a key in order to then re-reverse, essentially. Like, if that was an encrypted message, this would be the key for it, right? Basically, that's what that means. Yeah. Yes, okay, yeah. Cool, cool. Which does mean that... Yeah, so we were to rerun that, actually. And we go switch cipher, force keyboard. And we go decrypt, and we paste in that. But then we actually type in our key, so... Q:D. Actually, let's just do Q:D lowercase. Oh, yeah, okay, that's my bad. I know what's going on. It's because I changed it down here, but I didn't actually change anything here. We actually want to replace this with input because I still want the key to be usable. Like, if you have a key, you should still be able to paste the key and have it work. That's at least the plan. Keyboard change. Paste in there. Okay, so this will be switch cipher, so the keyboard change, decrypt, that, and it's Q:D. And we get LP as best, yeah. Cool, there we go. And then just to make things like, you know, let's just do a 2 upper. There we go. I'm pleased with that. There we go. That's our keyboard change cipher. Let's just do a quick build. Copy over. Right. There we go. And then I know that we were going to do what was next. So we got that one done. So we were going to work on 2 more ciphers today, but I think I might leave them for next time. Specifically, they were a triliteral cipher and a Baconian cipher. Both basically do the same thing. The triliteral cipher converts the A to Z alphabet into 3 letters. So A becomes AAA, B becomes AAB, C becomes AAC, D becomes ABA. Yeah, E then becomes what? ABB. F becomes ABC. And then yeah, so let's see, so ABC, and then G becomes ACA, H becomes ACB, I becomes ACC, J becomes BAA, etc, etc, all the way up to space. Like, you know, you have the Z, which is CCB, and then the space becomes CCT. Yeah, basically that's the triliteral cipher, and then Baconian cipher is somewhat similar, just with A's and B's. Basically, it's basically exactly the same. A is 5 A's, B is 4 A's and a B, C is AAA BA, D is AAA BB, E is AABAA, and it just repeats like that. And because of the way numbers and letters work, there are actually some letters, I believe, that are substituting the Baconian one, just because there aren't enough characters, there aren't enough combinations of A's and B's, I think. Is that right? No, that can't be right. Really? Hang on a sec. Hang on a sec, hang on. So AAA, AAB, AABA, BB, BAA, BAB, BBA, BBB, yeah. BAA. Yeah, and then B, yeah, hang on. Yeah, like, I don't know why they substitute letters out, because there's definitely enough combinations, I'm pretty sure of it. Because then that becomes BBAAA, BBAAB, Yeah, okay, for some... Anyway, long story short, basically I and J are the same letter, and U and V are the same letter in Baconian, but for some reason they do that. I don't know why. You don't need to. I don't get it. And then, yeah, like, it turns out there's a second version of the alphabet which does actually make use of I and U. Like, I, J, U, and V are separate letters, you know? I was going to say, I'm pretty sure there was enough character combinations, enough A, B character combinations in a 5-letter string. Weird. We're going to do the one that makes use of all of the characters, not just, it doesn't, you know, we're not going to make use of the one that combines I and J and U and V. We'll also include a space as well, because there are leftover character combinations using A's and B's to include spaces, so we'll do that as well. But yeah, that'll be the plan for next time. So the triliteral cipher and the Baconian ciphers, both that use that convert the individual alphabet letters into strings of letters in a binary sort of way. You know, like how triliteral is ABC, and it, you know, iterates like in a binary kind of way. Base 3, basically. Base 3. Baconian is base 2, but 5 letters long. So A's and B's, but 5 letters long. Anyway, that's like I said, that's where I'm going to call it for today. I think it's been good fun. I've worked on this quite a bit recently. I don't think I'm going to add any more ciphers before the next stream, because all that's left before we get to the really hard ciphers is the triliteral and Baconian ciphers. Those are the last easy ones. After that, we then move on to the Vignere cipher. Is it Vignere? Vignere? Yeah, Vignere. Vignere cipher. I think that's how you say it. I have no idea. That's when things get a little bit more tricky. Encryption with the Vignere uses a key made of letters and an alphabet. There are several ways to achieve ciphering manually. In order to cipher a text, take the first letter of the message and the first letter of the key, add their value. Letters have a value depending on their rank in the alphabet, starting with 0. The result of the addition modulo 26 gives the rank of the ciphered letter. Okay, and then continue with the next letter of the plain text and the next letter of the key. When arrived at the end of the key, go back to the first letter of the key. There are grids and tables you can use to help out on here in front of me to help you sort of map it all out. It gets a little bit more complicated though. And then from that point on, from the Vignere is the easiest of the hard ciphers. We've then got an ADFGVX cipher, which is a grid-based. If anyone knows what a Polybius square is, that's also on the list, by the way. Polybius is on the list. If anyone's aware of a Polybius square, an ADFGVX cipher is similar to a Polybius, but instead of using numbers to represent the grid spaces, you use ADFGVX, so it's a 6x6 grid. Yeah. There's also an ADFGX cipher, which is the exact same, but you just skip out the V by the looks of it. Yeah, you skip out the V, so it becomes a 5x5 instead of a 6x6, but it's exactly the same like encryption method. You got a Bazaris cipher, which 2 identical grids. Hang on a sec. So a Bazaris cipher and a Polybius cipher, I think they're exactly the same. Okay, no. So specifically, a Polybius cipher, I believe, is a 5x5 grid, and I believe the letters are all done in order. Yeah, the letters are all done typically in order, as in A to E, F to J, etc., etc. Whereas a Bazaris cipher, so we might actually do the Polybius first. I had it flipped. I was going to have the Bazaris cipher be first. Bazaris cipher is the same, but instead the letters are all shuffled, from what I can tell. So it might not be A to E. It might be A, F, L, Q, V, B, G, M, R, W, C, H, N, S, X, etc., etc. you know, that's a zero cipher. And then we got the periodic table cipher. This one's going to be fun when we get to it. You basically form you take your string and you basically split it up into as many different as few periodic table elements as you can. So let's say, for example, you've got hello, you would have helium, and then is there a single L? There might not be. That might be a bad example. Okay, I can't find a single L or two L's. Okay, hang on. Is there an EL? Hang on. If there's an EL, then we can make this work. And an LO. Hang on a second. No, I can't seem to find an EL. I also couldn't find an LO, but no. Anyway, my point is, you basically try and convert your string into the periodic table, like elements. So let me try and find a word that works. Let's take, for example, let's take, for example, the name Ben. Super simple. It turns out it's really easy on the periodic table. You've got Be, which is, hang on a second, beryllium, and then you've got N, which is nitrogen, I'm guessing. Yeah, nitrogen, yeah. Those are the two elements, so you put in the string Ben, and out you get is BeN, right? Be has an elemental number of 4, N has an elemental number of 7, so our return, our encrypted string would be 4-7 or something, right? We would have to probably include some sort of separator, similar to how our A1Z26 cipher works. We need to be able to separate, you know, numbers. So you do, like, you know, 4-7. And that's our periodic table cipher. Simple as that. And then to convert backwards, you just have to, like, split the string by our delimiter and just basically get the matching periodic table element. Simple as that. And then get the string for it. And as if that wasn't going to be hard enough, what's the Rosier cipher? I had this one right at the end. Why did I have this one right at the end? There was a reason for it. Oh yeah, it's because it's like a double encrypted Vignere cipher. Oh, I believe the Rosier cipher is basically Vignere, but instead of just saying, okay, well, give me the input and the key and then match them up, you then say, right, give me input key, input key, input key. That's our encrypted letter, first letter. It's like, what? There's something like that. There's like a loop to it. So hang on a sec. So the Rosier cipher is a variant of the Vignere cipher. To encrypt a message, locate in a square of Vignere the column of the letter of the plain message. Go down until you find the letter of the key, then move horizontally until you locate the letter that follows in the key, and finally go up horizontally to read the letter of the column which is the encrypted letter. What? I think what it is you... Okay, find the column of the letter of the plain message. So let's say, for example, you're encrypting H, right? You go down until you find the letter of the key. So you'd like go down, let's say your key is key. So you find the column H and you go down to find K. Then you go horizontally until you locate the letter that follows in the key. So you'd find E, and then finally go up horizontally to read the letter of the column which is the encrypted letter. So then you go up and find the encrypted letter out of that. It's weird. We'll figure it out. We're gonna figure it out properly. It gives examples so we can follow along. We'll do all of that next time. Well, no, we won't do that next time. I promise you we're not going to reach the Rosier cipher next time. I very much doubt we're going to get past the Vignier cipher. Next time we're going to do Triliteral, Baconian, and then we'll see about the Vignier. We'll probably get onto the Vignier. And then time after that, we might then work on the ADF GVX one, along with the ADF GX one, because it's the same, just with one letter trimmed out. And then again, Polybius and Basarius, we might as well get those knocked out at the same time, because it's just number substitution instead of letter substitution. It's basically the ADF GX one, but with numbers. Polybius is just A to Z on the grid. Basarius is shuffled letters on the grid. Then after, like, time after that, we'll probably then work on the periodic table cipher, and then I imagine time after that we'll work on the Rosier cipher. We'll see. Anyway, after all of that rambling, like I said, this is where I'm going to call it. Let me just get my stream deck up. There we go. Thanks for watching, everyone. I do appreciate it. I'll be live again Wednesday. I'm not sure what we're going to do. We won't be programming. I know that for a fact. Just because Wednesday's my last day in office this week. I've got Thursday and Friday off work, and I'm not going to want to do any programming after Wednesday. I don't know. We might do Final Fantasy 2. I've been meaning to do that for a couple of months. I'm not sure. It's in the air at the minute. It's Final Fantasy 2 at the minute, but we might change it up. We'll see. We'll see. You know, it'll be alright on the day. But yes, thanks for watching. I do appreciate it. Hope everyone has a wonderful evening, afternoon, morning.